Linked list is one of the most fundamental linear data structure. It is designed to overcome the problems that we found in arrays. The problems with array, it is a method where we waste lots of space, and it is because when we declare an array, we must have to specify the upper bound. We need to specify the upper bound of the array. However, while we write the program, we do not insert all elements. As a consequence, the lots of spaces are wasted because we do not use those locations at the time of running the program. That is one disadvantage. To overcome that problem of wastage of space, the new data structure is designed. Data structure is called the linked list. In the linked list, what we do, static allocation of memory is avoided. Instead of that, we make use of dynamic memory allocation. Dynamic memory allocation. It means that while we compile the program, we do not allocate space for variables. No space is allocated to the variables. However, while we run the program, we allocate space. This is called dynamic memory allocation, which avoids the space wastage or memory wastage in the program. In order to implement the concept of linked list, what we do, we use a structure in C programming language. Since we are talking about data structure implementation using C, that's why in C we will be using a structure in order to implement the concept of a linked list. Struct, say list, for example. In this structure, we have one example integer type data or information. Then we define a pointer that points to the next element. Let this field, let us say this name of the field is next, to indicate the next element of the list. Next, so the type of this pointer will be as same as this one. So the same thing will come here. I'll write down struct list here. Struct list star next. So this is the declaration of the structure that represent one element in a linked list. If I want to use this structure in a program, I must have to declare one variable of the type list, say L1. However, while we use linked list, our main purpose is to minimize the space wastage. That is why all the elements in the list are declared as a pointer. So that will ensure us to leave the space allocation at the time of compilation. Rather, we can keep that space allocation at the time of execution of the program. This is the main memory. It will reserve some space. Name of this location will be L1. This one L1. However, this location we can store an address. And what address will be? This address will be nothing but a address of a location. We should store the address of a location here, where we can store a variable of the type or data of the type struct list. So once we have this declaration, now I can see that this location is pointing to no other location because we do not have an address here. So if I want to store an address in this location L1, I will make use of the function malloc. I will write down the function malloc, then I will tell reserves some space which can hold a data of the type struct list, right, which can hold data of struct list. If I execute this statement, then there will be a space allocated. This is the space allocated as a result of statement malloc operation. Size of struct list indicates that if it is 4 bytes, assuming the pointer takes 6 bytes, 6 plus 4, 10 bytes will be allocated. 10 bytes, this is 10 bytes. But at this point of time, this location is not ready to store our desired structure list. So what I need to do, I will tell the compiler that you convert this allocated space by malloc into struct list star. Then this space will be divided into two different sections. First one will be for the data, which is of 4 bytes, and the name of this location will be given as data, and second one will be of 6 bytes, which will be reserved for some address. So here the name of this location will be the name of the first one. This is data say, and the second one will be the next, which is a pointer. Okay, now if I want that this L1 stores the address of this location, then what I need to do, I need to write down the statement here as this is equals to L1. If I say this, then this address, let us consider that this is 4000, then this 4000 will be stored in this place. And here we have, this is data, this is a pointer, next, right? And we have also written the statement that this address is stored here, and if it is stored here, then it seems to point to this location. If I see the program here, this was the program. We define this structure, then we declare one variable, then we initialize that pointer variable which is declared here, then this is ready now, ready to use. Now next point, what I want to do, I want to store some data here. I know that this is a pointer, L1 is a pointer which is defined as struct list star L1. Also we have this declaration in the program in the previous part, struct list star malloc size of struct list. This is a simple statement, but it seems to be difficult. This returns number of bytes, this converts into a form where we can store data of struct list type, and the first address will be assigned to L1. That's why we have 7000 here, assuming this address is 7000. Simple. Now I want to store data here. I have a pointer to a variable of this type structure, then I can access this field as P, then name of the field. So this pointer is nothing but L1, and name of that field is data. If I say this, then If I say L1 data is equals to 60, then this statement will print or store 60 in this location. Similarly, if I want to access this location, then I can say L1 next. That means this field, which may be equals to null. That means it will point to nowhere. So if I see this list, then it looks like this L1 is here, L1 is here, L1 is here. So this is L1. So this is a link, this is a list, or this is a data which is pointing by L1, which is pointing by L1. This is the pointer. Now if I want to similarly retrieve the content, I can make use of this pointer to retrieve the content, same as this statement. If I want to have one more data, then I need to declare, I need to have one more statement here in the declaration. I have what? Struct list. I must have to have one more declaration of this type, L2 say. The same statement I will repeat. It will create another location inside the memory. Since the statement is same, it will divide it into two parts. It will be divided into two parts. Okay, these two parts, and L2 will be this one. Let us suppose that this address is 9000 and L2 will be 9000. L1 is 7000. Then I can repeat this statement again. L2 data is equals to 90 here, and L2 next is equals to null. This one I have repeated. But however, what I want to do, this element, since it is a linked list, I want to place this address 9000 in this location. If I do that, then it will look like 9000. This is no longer null. It seems that this 9000 is a pointer that points to this location. Now this element L1 and L2 are said to be linked. 60 is linked to 90. So now that this is the first element of the list, this is a second element of the list. If I print these two elements, first one will come as 60, second one will be coming as 90, and then no more element. But how to do that? First of all, I have to place this value in this location. I know that this value is stored in L2. This value is stored in L2. I want to store that L2 value stored in L2 in location this. What is the name of this? How can I access this location? Using L1 next. L1 next. Okay, L1 next. So if I do this statement, this is the second element. If I do L1 next is equals to L2. So L2 is 9000, and 9000 will go here, and it seems to point to this location. So this is now 60 is linked to 90. Let us suppose I want to have one more data. Then again the same thing I will repeat. I will do L3 pointer, same declaration, same statement. As a consequence, somewhere in the main memory, we will have one variable which is divided into two parts. First part is data, second part is the address. It is equals to say 6000, and L3 will be equals to now 6000. 6000. So this is the third element in the list, and I will repeat the same. L3 data equals to some value, say 100. Let us say this is 100, and L3 next is equals to null. Where to add this? Where to add this? If it is a list, then definitely 60. After 60, I'll go to 90. After 90, I'll go to 100. Let us suppose that this is the sequence. So this field, which is denoted by L3, denoted by L2, L2 next is equals to L3. If I do this, then this 100, this 6000, this address will come here. 6000 will come here, and it looks like that this is pointing to this element. It is not a very good idea of doing programs, because I can see I am repeating the same statement starting from here, this statement, after that this statement, and then this statement. I am continuing this the entire steps. So the best way is to use a loop, and use a for loop. I can use a while loop. I can use a do while loop. Any one of the loop is sufficient for implementing this concept in any program, that is repeated execution of the same state of same group of statements. So in linked list, normally we go for either do while loop or while loop, do while or while loop. In fact, you can go for loop also. So now let us see how can we do the same statement using a for loop. So I'm declaring a pointer head of the type struct list. Now this time my main purpose is to create a linked list or multiple elements using a loop. I'll write down one statement. Let me declare one more variable, or write down the malloc operation, or this is the location which is reserved by the malloc, and it is divided into two parts, and head. If this is 100, then head is equals to now 100. Then I want to put some data in this field, and in the next field initially it will be null. So I will write down the statement accordingly. I will write down head data is equals to, say, 90. This, let me not write down the scanf statement. Let me write down head data is 90, then head next is equals to null, right? This one, but I want to repeat this number of times. If I do that, then say I write down here for I is equals to 0, I less than 3 elements it will insert I plus plus. For simplicity, let's make it a for loop, and so I need one variable here, integer I. It will create another variable here. It will, the second variable, second time when I is 0, it will create the first element. When I is 1, it will create the second element, like this. And again 90 will be stored here. 90 will be stored here. This one will be null. This head is will come here. Head is equals to, let us say this is 200. Head will come 200. At the same time, this pointer cannot be in two different locations, so this one will not be there. This one will not be there. So if I repeat the loop in this way, then it will look like as we have only one element in the list. This is I. This is I. Initially I equals to 0. It will come to this I less than 3. So it will come here. It will create this node. It will put 90 here. put null here, it will repeat. Now this is equals to 1, it will go up again, it will create head, this one, and then it will put 90 here, null here, then head is now this one. This one I will be again 2 incremented 1, then again it will create one more element like this. Same way it will create one more element. This is the element, and now this head will come here, and let us suppose that this is 300. Again it will repeat for I equals to 3. No, it will not repeat for I equals to 3 because I less than 3 is false. So these are 3 elements scattered. However, these links are missing. Links from this element, this element, this element are missing. They are considered as, finally, when I will be trying to read elements, we will have only this element seems to be exist, but these elements are there in the main memory. We are not able to access except this element. That's why I understand that this loop is not correct. So what I need to do, instead of, let me say, let us keep this one head here, and let us take one more element which is a pointer. Let us take one more pointer, say p. It's a temporary pointer. And instead of head, I will make it p, and instead of it I will make it, instead of this head I will make it p, I'll make it p. So here also it will be p. Then when it executes for the first time, head, this element, and also p is now here, p is now here, and value of I is equals to 0, and once it is executed it becomes 1. Now in this case I am writing the scanf statement. Instead of this statement, let me write down scanf %d ampersand of p data. That will read the content. I will put the content, say, let us suppose I put the content 60 here, then I will repeat this. But what I will do before repeat, I will check, is this null? Is this null? I'll write a statement if head equals to null, then this is head, this one. Then what I will do, head equals to, head is equals to p. Head equals to p. That means this one will be equals to head now, and this 100 will go here. This 100 will go here. And it seems that this p and head is pointing to the same location. Then I will be 1, it will continue the loop. Now again it will create another p. This is the new p. It has 2 sections. I will have p here, and p is equals to, let us suppose that this point, this value is 200. Okay, and I is now 1. This is I. It will repeat. Now it will check if head equals to null. Head is not null, it is 100. So I will go to the else part. Else part. What I will do in the else part? What I will do in the else part? I will add this. This is pointing by head now. This is p is no longer here. P is here. So what I will do? This one, this point, I will put 200. So that I can do by the statement head next is equals to p, right? Then I will come to the end. This one will now move to, this for loop will move here. This is the end of for, end of for. Then I will repeat. This time I is equals to 2. With 2 also it will continue. Let us suppose that I have entered 70 here. Now this seems to point to this one. It will repeat it. It will repeat the loop. As a result of repeating the loop, it will create one more node. P is here, P will come here. It is no longer in this location. Let us say this is 300. I will execute this statement. Say it is 80 now. It is 80 now. This one is null. Do not have a pointer here. I have a pointer at this place. This field is null. And I have a pointer here. I want to place this address 300 in this location. In this location. How can we do that? How can we do that? If I see the program with the value of I, which is equals to 2, it will execute this loop. It will execute this loop. It will create the element. It will put 80. Then it will come to this point. Head equals to null. It's not true. So it will not execute this part. It will come here. At this point, if I do head next equals to P, that means this 300 will be stored here. So this we will lose. This element we will lose, because in that case, if I do that statement, this statement, if I execute this statement, we will lose the element 70. So we cannot do that. What I will do, instead of writing a single statement, I will take another variable q, which is equals to start or head. We will take one pointer q here. Q. Certainly we must have to have one pointer q. And within this, after this statement, what I will do, I will continue forwarding this pointer q till the end. Till the end means if I forward once, then q will come here. This is the end of the list. End of the list. So now when the q points to the last element of the list, I will tell q next is equals to p. That means in that case p will come here. So what I will do to go to the end of the list, what I will do, like while q next not equals to null, then q equals to q next, right? While q next not equals to null, q equals to q next. So what will happen here? If I write, first of all, I will write q is equals to head. Q will point here to the beginning of the q is this one now. Q is pointing to 100. I will write while q next not equals to null, then here I will write q equals to q next. Q equals to q next. Then this is the end of this loop, while loop. So when q is here, I will check q next. What is q next? Is it null? It's not null. It is not null. So I will write q equals to q next. Right now q is equals to 100. Q next equals to 200. If I write q equals to q next, it will become 200. If q is equals to 200, that means now q is pointing this location. This is 200. Q is pointing here. Then I will check. I will repeat this loop. Q next equals to null, not equals to null. Is it true? No, it is not true, because at this point q next is null. If it is null, it will go out of this loop. It will be here. Here I have this statement. Now instead of head, what I will do, I will write down q next equals to p. This is q next. I will put p here. P is 300. So it looks like this 300, this element is now pointing to this. And at the same time, we did not lose this element. Why? I still have pointer head pointing to the first element, and I can move from here to here, from here to here, and this is null. So this is the third element of the list. Now let us execute the same program at this point of time. I is equals to 2. Let's make it I is equals to 4. I is equals to 4. If I with I is equals to 4, that means 2 incremented to 3. So this is true. It will execute this loop. It will create one more element here. It will create one more element. It will divide into two parts. First part is data. P will be in its new location. This is P now. Let us suppose this address is 400. Execute this statement. Let us say I entered 90 here. I put null here. Due to this statement, I will check if head equals to null. Head is 100, so it's not null. It will come here. Well, it will be coming here. It will execute this statement 1, 2, 3. Actually, this one, this group I am writing here. The entire statements I am writing here. It will say q equals to head. This here we have only head. Here we have only head. This q is no longer here because I am again reinitializing all the elements. P is here. This is P. This is P. Because we have created this element in this place. This is head. We have not moved head. And I am pressing Q here. So it will execute Q equals to head. Q means Q is here. Q next not equals to null. This is 200. That's why it's not null. It will execute this statement. So Q will move to this place. So now Q next not equals to null. So it will again perform the same operation. Q equals to Q next. Q equals to Q next is 300. This 300. This location. So Q equals to now 300. If it is 300, it will come here. This is the new Q. At this point of time, Q next not equal to null is false. With the Q located here, it will come out of this loop. Once it comes out of this loop, it will execute this statement. This statement is Q next equals to P. Q next is P. P means 400. 400 will be placed here. So it seems that it points to next element. So we can continue. We can preserve the continuity of the list without losing a single element. So this is the list. This is the linked list. And when you consider a linked list, always assume that you do not have any pointer to any of the intermediate nodes in the list except the first element, except the pointer to the first element, and that is pointed by head in this case. I want to display the content of the list. First of all, in order to display the content of the list, what I need to do, I need to write down a printf statement for sure. Printf statement, printf %d, because the data stored in the linked list of the type integer. Then I have to use a pointer head, then data, name of the field. If I do this statement, then I will print this element. But what about this one, next element? What about this and what about this? So what I need to do whenever I want to read each and every element. I want to see each and every element of the linked list. What I need to do, I must have to take a pointer, temporary pointer, let us say Q, and I will put the value of head, Q equals to head. Then I will scan over the linked list. In order to scan or in order to traverse the linked list, I need to use a loop. Mostly I will be using while loop. While. Now we need a condition so that we can go to the last element. So if I want to go to the last element, that I know that the last element, the next field will be equals to null. So I can write down while Q next as previous not equals to null. Then I will print this, but instead of head, I will be using Q, since Q is using as a temporary pointer. And then I will write down Q equals to Q next. Q equals to Q next. If I execute this code, first of all, q will be here. Q equals to head means q equals to here. Q is here. I will check q next not equals to null is true. So it will go inside this loop. It will print the statement q data is 60. It will print 60. Then it will write down, or it will execute the statement q equals to q next. If q equals to q next is 200. So it will be q will be equals to 200 now. So q is here now. It is moved to this location. So q is no longer here, but head is still there in his own location. Then I will repeat the loop. Q next not equals to null is true again. It will go inside. It will print this value 70. Then it will update the value of q. Q equals to q next. What is q next? 300. So it will now become 300. If it is 300, then q is here. It is no longer here. Then I will again continue the loop. We'll check next not equals to null is true. It will print the element 80. Then it will increment this q, or it will move the q to the next element using q equals to q next, which is q next is 400 now. So q is in this place. This is q. Now q is here. I am here. 400. It will repeat the loop. The moment we are here, we did not execute this printf statement. So the list will end up with 60, 70, and 80. It will not print 90. What is the solution then? There are two solutions. One is what I can do instead of q next not equals to null. What I will do, this condition I will change to q not equals to null. Q not equals to null. First, q not equals to null means q will be here. Not equals to null means q is equals to how much? 100. So it is not null. It will execute and it will print 60. Then q will move to 300. That time also q equals to 300. That's why q is not null. So it will execute this statement. It will print 70. Then q will move here. This time also q is for 300, but not that's why it's not null. It will execute, so it will print 80. Then after that q equals to q next, it will q move here. This time also q is equals to 400. Please note, at this point of time q next equals to null. Q next is this field, but q not equals to null because q is 300. Q is 400, sorry. Q is 400, but q next is null. If I test q not equals to null, this is true. If it is true, it will go inside this. Then it will print 90. Then I will write down q equals to q next. Q is equals to q next is equals to null. If I go here, q not null is false. So it will come out of the loop. So in this case, it will print all the elements 60, 70, 80, and 90. So while sometimes it is while we write down the while loop to traverse elements in the list, it is necessary to know, should I write q not equals to null or q next not equals to null. Sometimes we have to use this, sometimes we have to use this. There is one more method, that is, this is one of the methods that we can print the list. There is one more method. That method is I can make use of do while loop instead of while loop. I left this one as assignment. You try that, how to print all elements or how to traverse all elements of the list using do while loop. Do while